in this example, we would like to graph the polynomial here. The first step will be to factor completely. We see a common factor of x squared, so we'll start by factoring out the x squared. We now see that we have a quadratic that can be factored into x plus 3 and x minus 1. Double check that your inner plus your outer is the middle term. It is. Let's notice that the zeros of this polynomial are x equals 0 with a multiplicity of 2, x equals negative 3 with a multiplicity of 1. Multiplicities are found by looking at the exponent on the factor that generates the 0. And our last 0 is x equals positive 1 with a multiplicity of 1. Recall that zeros with an even multiplicity will bounce off the x-axis. The function will bounce off the x-axis. And if we have an odd multiplicity, the function will pass right through the x-axis. Now let's take a look at the end behavior for this function. So the end behavior is found by looking at the dominant term. The dominant term is the term with the highest power. So the dominant term would be x to the 4th, and we can think of the function y equals x to the 4th, and think about what happens at the extremes of this function to the far left and the far right. Because this is an even power, we know that the y values will all be positive, and if we plug in a negative, we will have a positive, and if we plug in a positive, we'll have a positive. So the end behavior is up to the left and up to the right, if we look at the tails of the function. Let's also notice what the y-intercept is. So the y-intercept is found by plugging in 0 for x. And when we plug in 0, everything goes away, so we have f of 0 is 0. That tells us that the y-intercept is the origin. Let's go ahead and graph this function now. So we'll start by graphing the y-intercept. We know that the y-intercept is equal to the origin, so it's right there. And let's go ahead and complete the x-intercepts now. X-intercept of 0, we already have that. X-intercept of negative 3 is right there. X-intercept of 1 is right there. So now we have to apply the end behavior up left and up right to these zeros. And we know that the 0 at negative 3 has an odd multiplicity, so the function is going to pass through that 0. The middle 0 has an even multiplicity, so there's going to be a bounce there, a touch and go. And then the last 0, the rightmost 0, 1, that has an odd multiplicity, so it's going to go right through. So the graph is going to look roughly like this. Now, we don't know with this method of graphing, we don't know exactly where these low points are. This one may be lower than this one may be lower than that one. We don't really know. Those are ideas that you will explore in calculus. For us, we just want to get a general shape of the graph. We know the graph is smooth, there's no corners or cusps or anything, and we know that it goes up to the left and up to the right with the multiplicities as such. Kaboom!